Good day everyone, this is Nalger Caetano speaking. I will show you how to name a molecule that has both an alkane and alkyne. Alkane is a molecule that has a carbon-to-carbon double bond and gets the last name of ane. And then alkyne is a molecule that has carbon to carbon triple bond and gets the last name of ane. But do you name a molecule that has both a double bond and a triple bond? An alkane and alkyne can exist in the same molecule that you prioritize based on where each functional group shows up. We will use this molecule as our example. Since I only have one long chain, I highlight my parent chain and then decide how to number. I have the option of numbering from left, giving me a 1 for the double bond, or numbering from the right, going me a 2 for the triple bond. The priority here is to determine by which functional group you hit first, and so I have to number. From the left, because I have number 1, which is lower than 2. Having 6 carbons in my chain gives me a first name of hex. Having both a double and triple bond, I get 2 names for this molecule. I get 1 ine for the double bond and the 4 ine for the triple bond. When it comes to putting the molecule together, ine gets a higher priority than ine in the naming, and that is because alphabetical order, E comes before Y. In previous example, we've shown that you could put the number before the name, but because we have 2 last names here, each number has to precede its specific functional groups. This gives me a complete name of hex, 1 ine, and 4 ine. In this example, I switch the order of the substituents, so once again we have a straight chain with a alkane and alkyne. But in this molecule, since the alkyne is terminal, the alkane gets priority for numbering. And so I number starting from the right. Once again, 6 carbons gives me a first name of hex, and double bond and triple bond give me a last name of both 1 ein and 4 in. In this case, even though the triple bond has higher priority for numbering, E comes before Y, and so in still comes before ein in the name. The molecule is named by hex for in and 1 ein. And 4 in and 1 ein. Now look at this example. The first thing to do is to highlight the parent chain and determine which way to number going to the standard IUPAC rule. You have to number the chain so that the substituent gets the lowest number. In this case, I have to start numbering from the right because I have methyl group on the second carbon. Now let's put the name together. I have 8 carbons giving me a first name of oc. I have a double bond and carbon 5 giving me a last name of 5 in. Also, have a triple bond on going in a second last name of 3 ein, and then we have a methyl group on carbon 2 giving me the prefix 2 methyl. In putting this molecule together, methyl is your only substituent, therefore it's your prefix. In and ein are both your last names as sorted in alphabetical order, and this gives me a final name. 2-methyl oct, 5-ane, 3-ine. Now, what happens if I have an example that potentially gives the alkane and the alkyne the same name? Once again, I start by highlighting my parent chain, but now I have the option of numbering from the right, giving the triple bond, and number 2, or numbering from the left, giving the double bond, the number 2. In this situation, the alkane has the higher priority than the alkyne, and so we start numbering from the left. Having 7 carbons in my molecule gives me a first name of hept. Having both an alkane and alkyne gives me the last name of 2-ane and another last name of 5-ine. Since E comes before Y, I get a final name of hept, hept 2-ane and 5-ine. And that's all, Mom. Thank you so much.